Now let's talk about dividing rational expressions. The things you need to remember are those rules that you wrote down for simplifying rational expressions. Today we're going to apply the rules for the division of fractions, and one of those rules is if you're dividing a fraction by a fraction, you're going to keep the first one, change the sign to multiplication, and then flip the second fraction. So the numerator becomes the denominator becomes the numerator. In number 1, we have 2a over a plus 3 divided by a plus 7 over a plus 3. When we're dividing fractions, we're going to keep the first one. So we're keeping 2a over a plus 3. We're going to switch the sign from division to multiplication. And then we're going to flip the second fraction. So this will become a plus 3 over a plus 7. Now when we're multiplying fractions, you can just multiply straight across on the top and bottom. So this becomes 2a times a plus 3 over a plus 3 times a plus 7. Notice on the top and bottom we have the same factor of a plus 3. And anytime we have a fraction, we want to keep it as simplified as possible. So we're going to simplify this by getting rid of that factor because a plus 3 over a plus 3 is just 1, right? Any number divided by that same number is 1. So this just becomes 2a over a plus 7. That would be our final answer here because this is as simplified as it gets. In number 2, we have 2m plus 6 over m plus 5 divided by m plus 3. If this is not a fraction, this is actually the same thing as being over 1, so really it is a fraction where your denominator is 1. So we're going to keep the same first fraction, switch that sign to multiplication, flip our fraction. So now this becomes 1 over m plus 3. That's why it's important to realize that originally m plus 3 is divided by 1. So when we switch it, now it becomes 1 over m plus 3. Then we can multiply straight across. So we have 2m plus 6 times 1 over m plus 5 times m plus 3. Now right now it doesn't look like there's anything that we can cancel out, but we need to factor this numerator before making that final decision. So a GCF from both of these terms is 2, and when I divide both terms by 2, I'm left with m plus 3. Which is exactly the same as one of the factors in our denominator, which we can then get rid of, because m plus 3 over m plus 3 is just 1. So we're left with 2 over m plus 5. Here we have x over x plus 2 divided by x squared over x squared plus 5x plus 6. Just like normal, I'm going to keep the first fraction, switch the sign to multiplication, and flip the second fraction. Now I'm going to multiply straight across, but before I do that, I'm going to go ahead and factor this trinomial. That's my new numerator. So I'm going to see what multiplies to 6 that adds up to 5. So our factors of 6 are 1 and 6, or 2 and 3. Those factors need to add up to 5, so we're going to use the 2 and the 3. So now when we multiply across the top, we have x times x plus 2 times x plus 3 over, when we multiply across the bottom, we have x squared times x plus 2. Now let's see if there's anything that we can get rid of. I see x plus 2 and x plus 2. Those are both gone. I also see x over x squared. I can get rid of the x on top, and then on the bottom this will just become x to the 1, or just x. So then my final answer here, we still have the x plus 3 on top, and we were left over with one of those x's on the bottom. There's our final answer. Finally, we have 2x plus 4 over x squared plus 11x plus 18 over x plus 1 over x squared plus 14x plus 45. So this is our first fraction, and we're dividing by this second fraction. My first fraction isn't changing. We have 2x plus 4 over x squared plus 11x plus 18. We're dividing by this bottom fraction, so we're going to multiply by the reciprocal, which is x squared plus 14x plus 45 over x plus 1. I'm going to go ahead and factor both of these trinomials. So from the first one, I need to see what multiplies to 45. That adds up to 14. My factors of 45 include 1 and 45, 3 and 15, 5 and 9. When we're adding up to 14, we're going to use 5 and 9. So now across the top, I'm also going to factor this first binomial by taking out a GCF of 2. So we have 2 times x plus 2 times x plus 5 times x plus 9 all over. Then I'm going to use that other trinomial, see what multiplies to 18, that adds up to 11. Factors of 18 include 1 and 18, or 2 and 9. To add up to 11, we need to use the 2 and the 9. So we have x plus 2 times x plus 9, keeping that other x plus 1. We can eliminate x plus 2. We can also eliminate x plus 9. So then we're left with 2 times x plus 5 over x plus 1, or 2x plus 10 from distributing over x plus 1.